Okay everybody, well you should have watched the video on transformer construction. Well, I put a couple of videos up, one on construction of transformers, of a small transformer, and one is showing you how a large three-phase transformer is working. And you should have seen the fact that in a transformer, on top of it is what we call a conservator tank, or in Americans pronounce a conservator conservator tank. And this is placed on top of the transformer, and it allows for the expansion of oil, which is insulation oil is inside the transformer, which is the primary winding and the secondary windings are immersed in this oil, and a pipe comes out of the top through what's called a Buchholz relay, which we'll explain next week. Actually, we deal with that next week, so I'll explain how that works. But what you need to remember is the conservator tank, and the function of this is to allow for the expansion of this oil when it warms up due to the transformer operation. When it cools down again, the gravity feed will allow the oil to go back into the tank, back into the transformer rather, and that's what it's for. It's a bit like the header tank in your in the old central heating type systems that you have in houses. Okay, so you need to remember that. The other thing you need to remember is you might get a question on turns ratios. So if you have a transformer here with 1,000 turns and a transformer here with 100 turns, we sometimes call that, as that's 10 times bigger than that, that would be a 10-to-1 transformer. So you might get a question where you're given a number of turns and you're given the ratio, or you might be given the ratio and asked to work out the number of turns. So another way of talking about a transformer is something like a 10-to-1 or a 20-to-1 or 15-to-1, whatever, depending on the ratio. Alright, so that's that. Next thing is what's known as a tap changer, which I think we've dealt with briefly last week when we were doing transformer calculations. If you have a transformer with some windings on the primary, say that's an 11 kV transformer there, and on the secondary here we have a number of windings out here. Now this doesn't have a tap changer on it, but if I wanted to put a tap changer on here, I would simply make this part of the transformer movable up and down. So if I could move this up to here, maybe 2 or 3 windings up, the voltage coming out, there's our load, and if I could make this sort of movable up or down, then I could alter that voltage slightly. I can show you that on this model here. If you'd imagine this is the secondary of a transformer here, then the tap changer would simply be a contact, a mechanically operated contact, which is touching these windings here. So this, instead of the output being terminated at the back there, one of the terminals would be at the end of this pen, and it would simply touch the windings up or down, so it moves up or down slightly, and that would alter the output voltage very slightly. So for example, if your control system realised that the output from the transformer was going too high, say over 230 volts too high, it would move up slightly and reduce the number of windings. And then if the control system realises that the voltage is too low, it would go back down again and increase the number of windings, so therefore it would increase the voltage. Alright, so that's the function of a tap changer. It alters the secondary voltage of a transformer. Okay. I've got a couple of other things to talk about, so I'll probably do one more video after this. We're going to talk about faults, safe isolation, and the ring main system. Okay. There's also a task on transformers on solar. Thanks very much. Bye.